Hello friends, myself A.K. Agrawal, teaching physics. Today we discuss about the rules for significant figures. What are the rules when we are using the significant figures? You have to understand that. First of all, rule 1. All non-zero digits are significant. So in the example 1, I can say x equals to 2564. These all digits are non-zero. So here I can write there are 4 significant figures. So there are 4 significant digits. So whenever any value with all digits are non-zero, the number of significant figures in that is the number of units, number of digits. Okay, the second rule. Here you can see x equals to 6.028. Any zero lying between the non-zero digits are used as the significant figures. So here you can see the zero lying between non-zero digits, so it is counted as significant figures. So you can see also here there are 4 significant digits. So this is the rule 2, where you can find out the significant figures, how many significant figures are there. Now the third one. In third, you can see I have written x equals to 0.0042. So you can say any zeros lying left side on the non-zero digits are insignificant. So here all zeros lying left to the 4 here are insignificant. So only 2 digits here are significant. So you can say there are only 2 significant figure. Now the fourth one. Suppose if you are writing a number like 20 meters, or if you are, suppose I am just taking another example of 20, simply 20. So what is the difference between 20 meters and 20? You can see this is only a number. When only a number is given to you, all zeros after the non-zero digit are insignificant. So in 20 you can find there is only 1 significant figures. But if a measurement is given with units or on a certain parameters, then all zeros after the non-zero digit will be counted as the significant figures. So it means in 20 meter there are 2 significant digits are there. Now the fifth one. If I will write down x equals to 1.400, then all zeros in a decimal numbers where decimal is placed, all zeros after the non-zero digits will be counted as a significant figures. Here it is worth noting, in the previous one I have told you the zeros which lying on the left side are non-insignificant, but here the zeros that lying on the right side is considered as the significant figures. So clearly in this part 1.400 there are 4 significant figures. So when you are I can take an example like 2.30. If I am taking 2.30, there will be 3 significant figures will be there. Now the rule 6. If I am writing down in the standard notation 1.4 into 10 to the power 7. So this 10 to the power 7, any power which is raised on 10 is not considered as the significant figures. Only these 2 values will count you as the significant figures. So here I can say there are only 2 significant figures will be there. Now I hope you understand that fact. Now I will move on the algebraic operations on these significant figures. There are basically you operated like either you adding or subtracting into significant figures, or you are multiplying or dividing the significant figures. So first of all, I'm taking an example of addition or subtraction of significant figures. In addition or subtraction, if suppose I am taking an example 2.32 and 1.4, if I want to add these two numbers, in addition I have to see how many significant number are there in the two quantities after the decimal. After the decimal, you have to point it out. In the first one, as clearly shown, there are two significant figures after the decimal in the first number and the 1 in the second numbers. So when you adding or subtracting, in the results there is minimum number of significant figures after the decimal is considered. So if I will add these two, I will consider 2, this is 3.72. now the answer will be 3.7. when I will round off it out, I will get 3.7. so in the final result, I have to consider the answer should be in one significant figures after the decimal. Now if I will move to the product or division, when I divide or multiply two quantity like 2.3 into 4.32, I have to consider the significant figures in the whole numbers. As clearly it is seen, in the first number there are two significant figures, and in the second numbers there are three significant numbers. So when I will multiply these two numbers, I suppose I get an idea. Suppose I will after the calculation I got the point 9.325. suppose. Clearly, if there are two significant figures in the first number, totality, and 3 are in the second figures, so the result should be in the least number of significant figures. So I have to rounding of this number up to only two decimal place, only two significant figures. So our final answer for this multiplication will be 9.3. This is an rough calculation. You have to consider it. So in the number of significant figures, you have to consider the minimum significant figures in the digits. Thank you.